All right, so here we are, Foundation Math 27.7. Let's do some homework. Now, I didn't just assign number one, but I'm going to do some number one questions just so you have some practice. I don't want to do all your homework for you. So number one says solve each using the quadratic formula. So solve each equation, verify by graphing. I will do one, and I will show you how you can verify by graphing, right? We should know this, but let's go over it. So 1a. So quadratic formula, that means we're not going to try to factor this, which is not going to be possible anyways, right? Two numbers that multiply to -5 and add to 7. Well, you have 5 and 1, that's it. So 5 and 1 doesn't get you to 7. So the roots, or the solutions, are not going to be integers. They're going to be some crazy decimal, all right? So A in A is 1. B is, go ahead, shout it out. What's B? 7. It's positive 7. And C is -5. Very good. So the quadratic formula, as you know from the song, is x equals -b plus or minus root b squared minus 4ac all over 2a. Very good. And so we're going to plug these values into the quadratic formula. So x equals, so -7 plus or minus the square root of 7 squared minus 4 times 1 times -5 all over 2 times 1. Right. Okay, so we'll try and simplify this now. The square root, okay, what's underneath this square root sign? Let's do that. That's going to be 49 is 7 squared plus 20. Very good. It's a minus minus, so 49 plus 20 all over 2. So this simplifies further to negative, again, these are x equals, right? These are roots. So -7 plus or minus, this is going to be root, what, 69, I guess? So root 69 over 2. Now, if this can be simplified, so if 69 can be divided by a perfect square, then you can simplify this radical. Right now, I'm okay if to leave it like this. You probably should actually write them separately. So first of all, does 69 divide by 9? 16 or no? 9. I don't think so. So -7 plus root 69 over 2 and -7 minus root 69 over 2. Okay? Those are your two solutions. Now, to verify by graphing, you're probably going to have to turn this into a decimal. So let's turn these into decimals, because that's the only way we'll be able to check, because the graphing calculator or Desmos or whatever you use is going to give you decimals. Okay, so let's do that. Turn those into decimals. So there's our decimals. The actual equation is x, oh, not alpha, x squared plus 7x minus 5. So let's zoom 6, standard window. Look at that. Those are the two intercepts. So you can do this on Desmos a little bit quicker and easier too, but for your exams and stuff, you're going to be able to use this calculator if you have to graph. So we'll just go over how to do it here again. So second function calculate is the trace menu. We're going to find the zeros, and it says left boundary. Let's take a look at this 0 first. Sure, let's set that as the left boundary. Let's cursor over. This is the right boundary. Yep. So somewhere in between there, I'm looking for this one. I just hit enter again. And 0.6533. There's one. Confirmed. Second function, trace, is the calculate menu. Go to. Now, the left boundary, we're going to have to hold the cursor, whatever, go over here till the cursor blinks above and to the left. Come on, there we go. So that's to the left of this intercept, and then go to the right of the intercept, and then enter again for guess. -7.6533. It's confirmed. Okay, good? Okay. So again, you can use Desmos on your home computer if you're doing this at home. All right, so that's 1A. Everyone's good with that? Any questions? Okay. 2. So let's do 2. This is what you guys are to do, but 2. Okay. So we have, for 2a, we have a equals 1, b equals 5, and c equals -6. This is going to be very similar to the last one. So x equals -b is +5, plus or minus the square root of b squared, so it's 5 squared, minus 4 times a is 1, times c is negative 6. All over 2 times 1. All right, so when you're doing your homework like this, you have to write out exactly what I'm doing here. Show that you're using the quadratic formula. It is not good enough just to put your answers. Okay? You have to show exactly this. What's A, B, and C, show the formula, and then simplify. So this here you can simplify. This is 25 plus 24, right? So 25 plus 24 is 49, correct? Okay, all over 2. Now, notice that this number inside the root sign is perfect square. So the square root is actually going to be simplified right out. There's going to be no square root anymore because the square root of 49 is 7. Very good. So x equals negative 5 plus or minus 7 over 2. Wow, that's awesome. So negative 5 plus 7 over 2 and negative 5 minus 7 over 2. That gives us negative 5 plus 7 is 2 over 2. That's 1. Negative 5 minus 7 is negative 12 over 2 is negative 6. Okay, so the quadratic formula gives us these two answers. And just for reassurance here, this is a trinomial that can be factored, right? Look at this. This is x plus 6 times x minus 1. Because 6 times negative 1 gives us negative 6 when we multiply. And 6 minus 1 gives us positive 5 when we add. So these are the factors, which means that x equals negative 6 here and x equals positive 1. So this one, they work both ways. If you can factor it, then you can solve for the roots by factoring. This asks you to use the quadratic formula, so that's why we're practicing that. Okay. Now, before I move on, this will probably come up as a topic maybe in the next lesson, but because you might run into this, I need to tell you about the nature of this root, okay? So this is part of your notes, really, actually, but so if the value, write this in the margin or somewhere in your notes for whatever section, I don't care. Just write it down. If the value under the root sign is, and then put like a colon there. Okay, so 1, if it's a perfect square, just like this example was, then that means that the roots will be, most likely they'll be, well, they'll be rational. Okay, so they'll be rational, which means they can be whole numbers, integers, or fractions. Okay, so there's no square roots left in them and no like crazy decimals, non-repeating decimals. Okay, the roots will be rational. So that's a ratio of integers. Let's see, if it's 0, okay, if it's 0, then it's going to be rational as well, because it'll be just root 0, right? So it'll be just this number divided by this number or whatever, you know, more or less. So now this one, so if it's negative, what do you suppose would happen, or what do you suppose the roots would be like if this value was negative? So for example, if this turned out to be negative 49, what's the square root of negative 49? That's not possible. It's not possible. Well, it is possible because math is awesome, but it's not possible to have a real number answer. Okay? There's an imaginary part of the answer that is legitimate. So there's a complex answer, but it's not, there's no real answer. Okay? No real solution. So that means if you were to graph the original function that these values came from, then the parabola wouldn't touch the x-axis at all. That's what it means. No real solution, so there's no intercepts. Okay? Perfect square, 0, negative. Okay, the only other one I guess is if it's greater than 0, right, and not perfect square. Okay. So then you're going to have, I guess that would be some irrational roots. So that means that you're going to have the root sign in there. Root sign remains in the solution. Or it's a crazy decimal that's non-repeating or terminating. Okay, so like I say, I might focus on that in a lesson coming up here soon, but just so you know, just in case you're wondering, why doesn't root -49 work on my calculator? Okay, that means there's no solution. It means that the parabola, here's the x-axis, it means that the parabola is way up here and it doesn't touch it. Or it means it's down here, opens down, doesn't touch it. That's what it means. So the math will tell you kind of what the graph looks like and what the nature of the solutions are. Okay? Not to be. Okay, so for 2b, let's do that one. A is what? What's A? B. For what is the A value?
Wait, what about 9?
It's actually 9, right? A is 9, B is 4, and C is 0. Yes, very good. So x equals -4 plus or minus square root of 16, that's 4 squared, minus 4 AC. Don't forget the 0. So 4AC all over 2 times 9. So what does this tell us? Let's see, -4 plus or minus 16 minus 0. Oh, nice. You see how that's a root 16? So that's going to simplify, that radical is going to be gone. So x equals, so I hope I'm not going too fast here. I'm kind of cruising along here. But hopefully you're picking up what I'm putting down. So this is just going to be 0. 0. This is going to be 4. So not 0 yet. This is going to be 4 or 18. Does that make sense? Everyone see that? Root 16 turns into this 4. Okay, so -4 plus 4 over 18 and -4 minus 4 over 18. So -4 plus 4 is 0 over 18, which is just 0. And this is -8 over 18, should be simplified. That is actually what? -4 over 9? So those are your two solutions there. How's that going so far? Going okay? All right. Here's the rest of your assignment. Finish number 2 there, move on to number 3. If you have questions, let me know, but that's your 7.7 assignment, and you have the rest of the class to finish that. So just looking at C, B is 0 because there's no x term. And you have A, B, and C, and D as well. Okay, here's your solutions for number 2. Once you have done your work with the formula, you can check to see if they match up with the solutions down here. So number 3 says solve by factoring and see if you like the quadratic format better. So this one, again, I think we did this already, but you want to look for two numbers that multiply to -6 and add to +5. So that's +6 and -1. The zero product principle says you let each of these equal 0 and solve for x. So here is -6 and here is +1. Those are your solutions. That's the factoring method. Is it frozen? Oh, sorry. So for B, for this one, greatest common factor, take an x out and you're left with 4 plus 9x equals 0. So we are taking each factor, letting it equal 0. There's your first solution. And then 4 plus 9x equals 0. Solve for x, so that's 9x equals -4 if you take the 4 to the other side. And then divide by 9, you get x equals -4 over 9. So that's how you do B by factoring. And I'll just do one more over here on the side. This is a difference of squares, right? So this is 5x as your square root of the first one. And then 11 is the square root of 121. So one's plus, one's minus. So you let each of those equal 0, and you get 5x plus 11 equals 0. That's 5x equals 11. X equals 11 over 5. And 5x minus 11 equals 0. That's 5x equals, whoops, this one should be negative. I forgot my negative there. This one's positive. 11 over 5. So that's where you get your 11 over 5 is 2.2. Negative 11 over 5, negative 2.2. So that's just really quickly how to solve those by factoring. You might like the quadratic formula a little bit better, or you might like the factoring better. If you have to choose, you can pick either one. How many of you are on number 4 now? Okay, I have number 4. I'll do a couple questions for number 4 just to... any of these A to D that are giving you trouble right now? No. Anyone that you want me to start with? Let's do B then, yeah. Okay, so B has the crazy decimals, right? It looks really scary. Nah, not so much. So remember, you have to get all these over to one side. It doesn't matter which side. If I have a choice, I like to make the x squared term positive. So I would tend to move these terms over to the other side so that this becomes positive. It becomes positive 3.9x squared, and then this is a negative 1.4x, and then that stays a minus 2.7. So I just took this over to make it positive, this over to make it negative, and this stayed negative. So now you're going to have decimals, no problem. You got calculators, that's no problem. Plug them into your trusty formula. So it's going to be negative 1.4. It's going to be a positive, right, when it's all simplified. Plus or minus the square root of negative 1.4 squared minus 4 times A is 3.9. C is negative 2.7. All over 2 times positive 3.9. And then you get on your calculator and see what it does. And yes, you can use decimals here. Decimal answers, no problem. Okay, so the textbook answers may be incorrect here for sum of 4 apparently, but you guys got these decimals too here for solutions. Now we can check by graphing, of course, right? There's 2 ways to check by graphing, guys. We can graph, guys, remember it? Listen up. So remember this, you could graph this as a function, right? Y equals. And then you could graph this one as a function, y equals, and find out the intersection points and to see if the x values of the intersection points match with these values. And that's what I'll do. Oh, what did I just do? All right, so yeah, if we graph these 2 functions here, you can see this is the parabola here, the first one, and then the line negative 2.7, and the intersection points are right here, and these are the values that we've got. So 1.03 right here, and then negative 0.6717 right here. So that is confirmed by graphing there.